exercise 6.1, we have the following diagram: the triangle PQR, and in the diagram, the angle QPR, keep an eye on the middle letter, QPR is 2x, angle PQR is 90 minus x. Prove that PQ equals PR. So essentially prove that this angle here is the same as this one here. Now, if that is the case, this would mean that this triangle is isosceles and mean that this angle here should equal this one here. They should be the same angle. So we're going to choose as a letter of my choosing. We're going to call it angle A. Now we know that all three angles in a triangle add up to give you 180. So A plus 90 minus x plus 2x equals 180. What I'm hoping is that angle A will equal 90 minus x. And this will result in this triangle being isosceles. Let's find out. We add them together. So we're going to get A plus 90 minus x plus 2x is plus x equals 180. Move it all over one side and we get A equals 180 minus 90 minus x. And then we're going to get A equals 180, take away 90, which is 90 minus x. And now we know that triangle is isosceles. So PQ equals. Okay. Done for you. Now, question 21. What I always say is keep an eye on the following. Keep an eye on your z's or your n's. This means that your angles are the same, provided the top of the z is parallel to the bottom of the z, or the top of the n is parallel to the bottom of the n. This is what's known as alternate angles. Okay. Next thing you got to look out for is what's called corresponding angles. It's like an elongated F. Like this, the insides of the F's are the same, and these are known as corresponding angles. Finally, we have X, which is opposite angles, and in an X, the opposite sides are equal to each other. Red equals red. Likewise, on the last one, the two of them will equal each other and corresponding. And what we say is these are opposite angles. Okay, now you need to be very familiar with those to do these questions. Let's see what we're looking at here. Now it wants me to prove that PS is perpendicular to RS. First thing I'll look at for is where is PS located. PS is here and RS is here. Basically wants me to prove that the angle. To make this happen, I need to prove that the angle PSR, P to S to R, equals 90 degrees. This is to prove PSR equals 90 degrees. So that is the goal of my question. Okay, so next, first thing we can say is I can just call it I can rename them angle 1, angle 2, 3, and angle 4, or angle 3 equals 90 degrees. Right, stops you to write down all those big numbers. So what I can say is angle 1 equals 90 degrees. Reason, it's vertically opposite. X is involved. The opposite here because you can see the x. Okay, look for another vertically opposite one. We can say that angle 2 equals 75 degrees. Angle 2 equals 75 degrees. Once again, vertically opposite. Okay. Now, angle 4 equals, see the way it's in a straight angle? So it has to equal 105 degrees. Reason being, angle at 180 degrees. Now finally, all four sides added together. So angle 1 plus angle 2 plus angle 3 has to equal 360 degrees. And remember, the goal is to prove that angle 3 equals 90, so we're going to get 90 plus 75 plus 105 plus angle 4, oh sorry, angle 3 I mean, so 360. This implies that when we add all of them together, it's going to be 270 plus angle 3 equals 360. And therefore, angle 3 equals 90 degrees. Hence, PS is perpendicular to SR. Okay, days. Next one. So, what we know about these type of objects is that in a square, every angle is 90 degrees. In a rectangle, every angle is 90 degrees. In a parallelogram, the red angle plus the green angle is 180, or the red angle, the purple angle is 180, or the green angle plus the black angle is 180, or the black angle plus the purple angle is 180, right? And it's the same for the rhombus. Now, the difference between a rhombus and a parallelogram is that in a rhombus, all the lengths are equal, while in a parallelogram, two sides have the same length, but one side doesn't, right? Now, let's find out what we mean by opposite angles. First and foremost is opposite angles will be this. These are opposite angles. Are we good with that? So they're opposite angles. So first question we're asked is, are the opposite angles equal in measure? So are they? And the answer is yes. Opposite angles are equal in measure, right? So complete the following tables. Opposite angles are equal in measure. Yes, for A, B, C, and D. All sides are equal in length, only for A and D. All angles are right angles, only for A and B. Diagonals intersect each other at right angles. Well, let's find out. I believe it'll only be for the square, so let's find out here. Square, that's 90 degrees all day long, so we know it works for the square, which is A. It doesn't work for the rectangle. I don't think it'll work for the rectangle, if I'm being honest. No, we can clearly see that doesn't work. Does it work for the parallelogram? Nope. And does it work for the rhombus? Seems to work for the rhombus as well. So it works for the rhombus and the rhombus and the rhombus and diagonals bisect each other. And what bisect means is that if you imagine this length here, that the yellow part is the same length as the green part. And likewise, in the next one, the yellow part is the same as the green part. Basically, the middle, the point of intersection of the diagonals always cuts the diagonal in half. Well, we know that works for A and B anyway. And it also seems to work for the other ones, because we could always take out a ruler and measure that out, but definitely works for C and D. Okay, you're good to go. Now, a square is a rectangle, true or false? Yes. Here's the thing, true. Reason being, all angles are 90 degrees, and two pairs of sides are the same length. Here's a saying: all squares are rectangles, but not all rectangles are squares. Okay, so that's true. A rhombus could be a square. True or false? Justify your answer. Could a rhombus be a square? Okay, So the definition of a rhombus is a four-sided object, four-sided flat shape that has four equal sides. So that's true. A rhombus could be a square. This is true. Square has four equal sides. See, the deal is with the rhombus can have any length it wants. So it has to have the same length for all four sides, but it can have any angle it wants, including 90 degrees, which will turn it into a square. So once again, all squares are rhombuses, but not all rhombuses are squares. Alright? Now the last one. The line L bisects ABD. So this means that this angle 1 will equal angle 2. Angle 1 equals angle 2. That's given. Now I'm going to call this angle 3 and angle 4. And line K bisects CBD. So angle 3 equals angle 4. Prove that L is perpendicular to K. Well, yeah, that should be easy enough. So what I want to prove is that this angle here is 90 degrees. L and K are perpendicular to each other. So I want to prove angle 2 plus angle 3 equals 90 degrees. Well, here's what we can start off with. Angle 1 plus angle 2 plus angle 3 plus angle 4 equals 180 degrees. Reason being, right angle. And next thing we're going to do is we're going to sub out angle 1 and angle 4 because you can see they don't belong in the answer. Okay, we're going to change this. Angle 1 changes with angle 2, so it's going to be angle 2 plus angle 2, and then it's going to be angle 3 and change out angle 3 for angle 4 for angle 3, and that's going to be 2 times angle 2 plus 2 times angle 3 equals 180. If you're a bit confused by that type of language, think of it as 2x plus 2y equals 180. You can divide both sides by 2. If you divided both sides by 2, you'd get x plus y equals 90. So that's what we're going to do here. And we're just going to get angle 2 plus angle 3 equals 90 degrees. And that's what we're asked to prove. And we're done. So we did 24, 22, 21, 20, 21, 22, and 24.